X-Winder, the original desktop filament winder. This video shows how to design a 4-axis winding for flat and hemispherical ended mandrels using the X-Winder Designer software program. The X-Winder Designer software allows you to specify the type of mandrel, the filament properties, the winding pattern, and detailed geometry of the path of the delivery head as it traverses the mandrel during the winding process. This video also shows how to control the placement of the filament in the end wrapping process. Z-axis offset. After assembly of the X-Winder, you'll need to measure and input the Z-axis offset. This offset distance can vary depending on exactly where you installed the carriage limit switch. Open the settings page to the 4-axis tab and send the carriage to the home position, where the limit switch will be activated. Once in the home position, measure the distance between the center line of the delivery head roller and front face of the right mandrel post. This should be about 2 inches or 50 millimeters. This offset defines the origin of the winder's coordinate system, and all mandrel position measurements should be made from the front face of the right mandrel post. Mandrel dimensions. After the mandrel is mounted, measure and input the right end, the right equator, the left equator, and the left end locations. If you are wrapping around a flat-ended mandrel, the equator locations are not necessary. Mandrel diameter. For the mandrel diameter, measure and enter the right and left mandrel diameters, as well as the diameters of the right and left polar openings. If you are winding a non-circular part, take the perimeter of that part and divide it by pi and use that as the diameter. Filament width and thickness. For the filament width and thickness, measure the bandwidth and the thickness and input to the designer software. Delivery head path adjustment. Delivery head path adjustments are critical to a well-tailored winding, and there are several inputs to fine-tune the delivery head path to get it just right. The right and left endpoints of the delivery head path should be just far enough beyond the ends of the mandrel so that the delivery head does not collide with the mandrel during operation. Likewise, the delivery head should be offset from the mandrel surface so as not to collide, but close enough to deliver the filament without delay once leaving the head. For a new mandrel, it's always best to run several passes of a winding at slow speed with dry filament to perfect the winding or the tailoring process of the delivery head path to the specific mandrel. In addition to the endpoints of the delivery head path, the right and left delivery head advance points are critical to ensure alignment of the filament. Misalignment of the filament during the end wrapping process occurs when the left or right advance points are too far forward or rearward. In this case, the delivery head advance point is too far forward and can be clearly seen in this first pass. Conversely, the advance point is too far rearward as shown in this pass. However, in this pass, the advance point is just about right, as no misalignment of the filament is apparent. Winding pattern. Once the delivery head endpoints and advance points show good alignment of the filament in the first pass or two, more time can be dedicated to the specifics of the winding pattern. Each winding layer can have its own pattern, which can be a regular pattern or a hoop winding pattern, and a pause can be inserted at the end of each winding layer if desired. The pattern selection is presented in a drop-down with 3 parameters. The first parameter is the winding angle. The winding angle is defined as the angle between the filament orientation and the mandrel central axis as seen in the side view and is denoted by the symbol theta. The end wrap angle, as denoted by the symbol phi, is the third parameter of the pattern selection and is independently selectable in this drop-down. As seen from the end of the mandrel, the end wrap angle phi is the angular rotation of the mandrel between the time the carriage first crosses the mandrel equator and the time the carriage crosses the equator the second time en route to the other end of the mandrel. A second angle, referred to as the split angle or delta, is also defined. During the end wrap process, the delivery head first initiates rearward movement when the angle phi less delta is reached. When the entire end wrap angle phi is reached, the carriage departs the equator position and heads to the other end of the mandrel. The split angle delta typically has values from 10 to 50 degrees. The end wrap angle phi typically has values from 170 to 200 degrees. Let's look at what happens with several values of the end wrap angle phi. These results are typical only and will be different for other geometries and inputs. Here is phi at 170 degrees. Notice how the filament rides well above the mandrel central axis. Here is phi at 190 degrees. The filament has moved closer to the mandrel central axis. Here is phi at 210 degrees. The filament is now just above and adjacent to the mandrel central axis. Going back to the pattern selection, the second parameter is the integer grouping. There are two integers that define the pattern, the number of groups and the number of circuits per group. The two integers multiplied together equal the total number of passes required for a given filament width to provide complete surface coverage of the mandrel for any particular layer. The integer groupings are listed in ascending group order in the drop-down. Note that the winding angle is not independently selectable as it is in the two-axis winding, but rather a dependent variable in this case resulting from independent selections of phi and the integer pattern. There are only a handful of patterns and angles that are possible given the previous inputs. Each time phi is changed, the available patterns will automatically repopulate in the drop-down. A change in delta will not cause the patterns to re-enumerate. Clicking on the far left button for each layer will display a detailed end view of the layer properties. The angles phi and delta are shown in the end view. This is a 6x4 pattern with 6 groups and 4 circuits per group. The detailed end view window draws out the winding progression of the groups and circuits per group. In summary, successful windings are all about adjusting the delivery head path. Use several passes with dry filament at slow speed to trial and error the inputs. First, adjust the delivery head endpoints and advance points to avoid filament misalignment. Second, adjust the end wrap angle phi and the split angle delta to tailor the end wrap geometry. Once you've tailored the delivery head path to the specific mandrel, save the design file and you're good to go.